Around 4 billion years ago, material left over from planet formation slammed into Earth. These bombardments may have brought water to the young planet. Credit NASA. Early Earth suffered constant threat of attack from leftover planet-building material. From about 4.5 to 3.8 billion years ago, failed planets and smaller asteroids slammed into larger worlds, scarring their surface. Near the end of the violence, during a period known as the Late Heavy Bombardment, impacts in the solar system may have increased. The increased activity most likely came from the movement of the giant planets, which sent debris raining down on the smaller rocky worlds. Earth bears relatively few scars from its violent youth because weathering and plate tectonics have renewed its surface. But the three other rocky planets Mercury, Venus and Mars, as well as the Moon, still carry the signs of the increased collisions. By using crater counting methods to estimate ages on these scarred worlds, scientists have been able to estimate time frames for material slamming into their surface. Samples collected by Apollo moonwalkers also contain the chemical signatures from different meteorites. Together, the evidence indicates that impacts increased about 3.8 to 3.9 billion years ago, during the Late Heavy Bombardment, which is thought to have lasted between 20 million to 200 million years. Even the asteroid belt may show some wear and tear, with traces of chemicals that bind tightly to iron found on their surface rather than beneath it. In addition to finding that the asteroids took longer to accrete than previously suspected, recent research revealed that there also must have been lots of small or medium-sized bodies present in the solar system for these collisions to have occurred over a range of timescales. Christopher Dale, a researcher at England's Durham University, told Space.com previously. The LHB may have been key to delivering water to Earth. Models show that when the planet formed, it was too hot to hold on to the life-giving liquid. Instead, water must have been delivered by other means. In the past, comets were thought to be a significant source of the planet's water. If something stirred up the debris in the outer solar system, and models suggest that the early motions of Uranus and Neptune could have flung material inward, the Isura comets could have deposited water on Earth's surface, while the planet's atmosphere kept it from evaporating. However, studies of comets, including Halley's Comet and Comet 67 Pc-Horomov-Gerasimenko, have revealed that most of them seemed to carry a different concentration of heavy water. While a normal water molecule is made of 2 hydrogen and 1 oxygen atom, heavy water had a hydrogen atom with an extra neutron in its nucleus, called deuterium. If Earth's water had come from comets, its deuterium-to-hydrogen ratio should be higher than it is today. This probably rules out Kuiper Belt comets from bringing water to Earth. Catherine Altwig, principal investigator of the Rosina mass spectrometer on board the European Space Agency's Rosetta mission to Comet 67 PCG, said at a 2014 press conference. Asteroids currently are the most likely suspect for delivering water to the planet. The small rocky bodies could have carried water and organic material to the surface during the LHB as they slammed into the surface. Today's asteroids have very little water, that's clear, Altwig said. But that was probably not always the case. During the Late Heavy Bombardment 3.8 billion years ago, at that time, asteroids could have had much more water than they could now. Those asteroids could have pounded the planets for even longer than originally believed. Although Earth's scars have long since been covered, researchers can study millimeter to centimeter thick layers of rock droplets known as spherules. Spherule layers, if preserved in the geologic record, provide information about an impact even when the source crater cannot be found. Brandon Johnson, of Purdue University, told Space.com. Johnson led a study that used models to deduce the impact sizes based on the properties of spherule beds. Some of the asteroids that we infer were about 40 kilometers (24.8 miles) in diameter, much larger than the one that killed off the dinosaurs about 65 million years ago that was about 12 to 15 kilometers (7.4 to 9.3 miles), said co-author Jay Melsa at Purdue University. But while giant impacts bring with them the idea of impending doom, other studies show that life could have still survived, or even flourished, in microbial form. Underground microbes would have flourished as their habitats increased thanks to the impacts. Even under the most extreme conditions we imposed, Earth would not have been completely sterilized by the bombardment, said lead author Oleg Abramov, of the University of Colorado, Boulder. But a new contender may be on the rise. Impact researcher William Botke, of the Southwest Research Institute in Colorado, thinks failed planets may have played an important role. We have evidence for 2 early bombardment populations and a time difference between them, a late one, plausibly made by escapees from the asteroid belt, and an early one from elsewhere, Botke said. Botke suspects that failed young planets, or planetesimals, may have contributed to the impacts on the backside of the Moon. These planetesimals would have been far larger than the objects in the asteroid belt, and would have done significant damage as they crashed into the rocky inner solar system worlds. If asteroids caused the LHB, the uptick in activity was most likely came from the movement of the giant planets. According to a recent model known as Grand Tack, Jupiter and Saturn moved into the inner solar system before tacking like a sailboat and returning to their final orbits farther out. Along the way, they would have scattered any debris found in an early asteroid belt, sending it flying toward Mercury, Venus, Earth, and Mars. Another model could explain the both incoming protoplanets and a handful of comets, which may have contributed organic material. Known as the NICE model, it calls for Neptune and Uranus to change places, sending the icy material that formed near them flying. Some of it would form the Kuiper belt, the outer region of the solar system where Pluto orbits, while others would travel inward towards the rocky worlds. The two models work well together, so both could explain the impacts that scarred early Earth. Follow Nola Taylor Reddit at NolaTred, Facebook, or Google. Follow us at space.com, Facebook or Google.